excited to come your way once again as we continue this wonderful journey in core mathematics. My name is Nanaya Wedu, and you can call me Nana. Remember to like this video, comment, share, and click on the notification bell, as well as subscribe to my YouTube channel so that you can get all videos on time. In our previous lesson, we've considered the types of vectors. We've looked at vectors like the equal vectors, the position vectors, the unit vector, and the zero vector. In this lesson, we want to consider how we can perform the various basic operations on vectors. So we want to look at how we can perform the operation of addition, how we can subtract, how we can multiply a vector by a scale factor or a scalar, and then the likes. But then we will concentrate on addition of vectors with this lesson. So let's look at how we can add vectors. So before we do that, we want to consider addition of vectors in terms of triangular form, right? So we have our triangle here. So let's imagine that a vector that we want to add is a vector from O to P, right? And we know the vector U, right, which moves from O to A, right? So we have the vector from O to A, which is U. So our vector OA is equal to U. And our vector that moves from A to P, right? A to P, we know that that is V. So from triangular law of vector addition, when you have a triangle, you know that to be able to get the side O to P, which is the vector we want to look at, we must move from O to A and then from A to P, right? So it means that our O to P as a vector should be equal to O to A plus A to P, right? So you have to move from O to A and then from A to P, right? So it means that our O to P should be equal to, right, our OA is our U plus our AP, which is our V. So it means that vector OP is equal to U plus V. Now that we've established this, let's consider a way we can add and subtract vectors, basically using the components form. So if you have a vector A, and we represent the vector A by A and then B, right? Where we know A represents the x coordinates of the vector and B represents the y coordinates of the vector, right? And then we have our vector X, which is X to be equal to the components X and Y, right? Where we know the first part represents the X component and the second part represents the Y component. Now to add A plus B, so we must add A component, the S part of it, so which is A, plus the top part of the S coordinates of it, which is X. And then we'll come and add the Y coordinates of the A, which is B, plus the Y coordinates of the X, which is Y. So we have our A plus B becomes A plus X and then B plus Y, right? And then we have an example here where we are asked to find P plus Q, P plus R, and then Q plus R, where we have been given P, Q, and R. So let's consider how we can solve this question. So we have been given our P, right? As we can see in the question, our P is equal to -4 and 3. And then we have our Q to be equal to 2, -3. Now first, we are asked to find P plus Q. So P plus Q, right? So we have our P and our Q, so we just need to add them. So what this implies is that we'll have our P, which is -4 and then 3, plus our Q, which is 2 and then -3, right? So this implies that we can have our P plus Q to be equal to -4 plus 2 gives us -2. then 3 plus negative 3 should give us 0. So it means that our P plus Q should be equal to negative 2 and then 0, right? As a vector, that is fine. And then the next one, we are supposed to find P plus R. Now, we know that the R given in the question is 10 and 8, right? So that implies that our P plus our R should be equal to P is negative 4 and 3, and then R is 10 and 8. So that implies that our P plus our R should be equal to negative 4 plus 10 should give us 6, and then 3 plus 8 should give us 11. So our P plus our R should be equal to 6 and 11. Now let's look at the final one where you are asked to find Q plus R. So we are asked to find Q plus R. Now we know our Q is equal to 2, negative 3, and then our R is equal to 10 and 8. So that implies that our Q plus R, we are just adding, right? So we have 2 plus 10, right, for the top part. 2 plus 10. So let me clean them right as well. So the top part is 2 plus 10. Then the down part is negative 3 plus 8. So that implies that our Q plus R should be equal to 2 plus 10 gives us 12. Then negative 3 plus 8 will give us 5. So it means that our Q plus R is 12 for the S component and 5 for the Y component. So in this lesson, we have basically looked at how we can add vectors. And we mentioned that for vectors, we just add the S component or the S coordinates part with the S coordinates, and the Y component or the Y coordinates part with the Y coordinates. In our next lesson, we want to look at some other examples on operation on vectors, basically addition. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.